we're producing these boards for EasyBus controllers that would also double up as development boards for AVR chips. But the issue arose about the LCD screen, because the LCD screen has to be soldered onto the PCB with quite a number of pins. And the issue was, well, some of the people who will be using this panel will be less experienced. And if we can't get this whole panel to work, how do we know whether the screen we sent them is actually working? How do we test an LCD screen before the ELF puts it into the bag for the kit locker? That's essentially it. So I said, well, why don't we just test them at the ELF's end? So what we put in the bag, we know the LCD works. So if they've done something wrong, we know it's not the LCD, or they've damaged the LCD or whatever. So how are we going to do this test? So that's what the board looks like. It doesn't come with the pins on it normally. It comes with just bare pads. So how are we going to do a test? So what I came up with was to make a little test rig for LCDs using these pogo pins, not to scale, of course, they're much, much tinier, but spring-loaded points that could actually connect to each of the holes in each pad, like that. So I got a piece of Vero board and I soldered on the pogo pins in the appropriate places where it would match up with the needs for connections to the LCD itself. So having got that there, how do we test that the LCD actually works? So that's the hardware end of it. It's just a set of pogo pins that connect to the LCD very temporarily, hold it on for making the test. So that the ELF doesn't have to solder lots of pins for every LCD that goes in every bag. You can just quickly put it on, make a test, and take it off, get the next one, put it on, make a test. That was the idea. And that's what it looked like. You just pop the LCD onto the pogo pins, press a button, and it tells you whether it's working or not. If that comes up on the screen, it's a working LCD. So to make that tester, we had to have something that would send out text to the LCD, and that's where the little nano came in. So going back to that, we want to connect some of these to the Arduino, but not all. There's the interface, and it tells you what each pin does from pin 1 through to pin 16. 0 volts, 5 volts for supply, another pin for just doing the contrast adjustments. I'll cover these in a minute. And then the data you're sending to put out different letters and numbers on the screen itself. And then the last two are for the LED, for the backlight. The main connections are then we're going to have 2 wires for the power, pins 1 and 2. Pin 3 is going to the contrast, and the contrast pin will go to either between nothing and 5. In other words, a little trimmer we can adjust to set the proper contrast. If you've used one of those screens before, you'll know that when you first power it up, you might see nothing until you tweak the contrast, then up comes the characters. And then pins 15 and 16 are the backlight, so you can see it in darkened situations. So we need all of these to be connected. We also need at least 4 of the data pins to be connected. If we go back, we'll see that it's actually an 8-pin connection. So you can send all 8 at the one time if we're willing to wire up all 8 pins. Or we can send it 4 bits and then 4 bits. It takes a bit longer, but there's less wiring involved. So we've chosen to use 4 bits for the data. And that's the table that sends out the characters. The column on the left, and then the row along the top. if you look at, for example, 0000 in the column and then 0011 in the top, it gives you the letter 0 on the screen, and the same for the alphabet and various other characters. So that's, if we're doing it 8-bit, we'll send the whole 8 bits at the one time to get that A or B or C. If we're doing it in 4-bit mode, we send the first and then we send the second lot. So we send the column first as data, and then we send the row as data. And that's what the software does for you. So there's 3 other pieces we want to look at. The middle one is called RW. You can either write to the screen or read from the screen. I don't know if anybody's ever want to read from the screen. So normally you set it to 0 because you're always writing to the LCD. The enable pin does what it says. You use that to actually enable the transfers. And then the RS is either commands or data. What that means is sometimes you're writing to the screen to put on words, MERG, or numbers. But other times you're sending out commands. In other words, clear the screen or move to that particular coordinates in the screen. They're commands, they're not the actual characters that will be displayed. So you have to switch between sometimes sending commands to the 1602. Well, it's called 1602 because it's 16 characters by 2 rows. You're sometimes sending commands to the LCD, and sometimes you're sending the actual data that will be displayed on the screen. But that's all done for you in software. So that's a little bit of VERA board. You can see almost 0 components. We've got a little trimmer up there to set the contrast. We've got a 5-volt regulator to power the LCD, and then a slot for the nano, and nothing else, and the pogo pins down the side here. That's all we need on the hardware side. And that's how it's actually wired up. If you actually saw it, we're using 4 data pins from the nano to be the 4 data inputs for the LCD, and some other data pins to do the read write and the enable, and then the 5 volts that feeds in to the backlight and also feeds 5 volts to the trimmer to set the contrast. So the wiring is pretty minimal and component count very minimal. And the software for it is all done for you. If we add into and include for the liquid crystal display, it knows all the things I spoke about earlier about enables and read write commands versus data, and whether you're sending 4 bits or 8 bits, it's all done for you. All you have to say is include liquid crystal code, and then you'll say, and make an instance of that called LCD. And then what follows after that is a set of numbers. The first one tells you whether it's the RS. Data 12 goes to RS. D10 is going to the enable. And then 5, 4, 3, and 2 nano pins go to data 4, 5, 6, 7 of the LCD. So you've told it what to expect. From then on, it's simple sailing. You just give commands. The simplest ones, I'm only covering a few of them here. LCD begin, and you're telling it you're using a 16:2 layout. And then LCD, clear the screen, that's what it says. Any previous data is written off the screen. And after that, you can either decide to print something or say where it will be. So the third line there says, go to 0, 0, in other words, top left-hand corner of the screen. So and start printing from there. And then you display whatever it says with LCD print. And then the next line says, move down the line. So we're still starting position 0, but in line 1. In other words, the second line, because everything starts numbered from 0. And then you print some more text. That's it. That's the code. That's all we need for the code to actually do an LCD tester. It's as simple as that. Of course, we don't have to put the word this LCD screen is working. It could be any text you want, depending on what you're doing. It could even be variables. So you could say LCD print out the voltage, or print out the number of times you've done something, or whatever variable you want as the program runs. So knowing these commands to begin, to clear the screen, and then move anywhere on the screen you want. You can write text anywhere on the screen, or numbers anywhere on the screen, or variables anywhere on the screen. And there's the example of it. What I did, I used a piece of foam, because when you're holding the LCD onto the pogo pins, it can tend to wobble. So I'll just put it underneath so it comes down vertically. I can show you that working. I can bring up that. I can connect the power. Right. So now put that little pad on. And it's only a matter of making sure that you align the pogo pins. There you go. And you can take that away and do the same, another one, another one, another one. So the idea is I'm going to send this to whoever becomes the elf. Whoever becomes the elf for making up these kits, I'll just send them that tester and they can test them. So the reason for showing it today, because you're not going to be the elf presumably, twofold. One is to show again the use of pogo pins, because they're spring loaded, and therefore you can make sure that when you put on, there's a whole range of pads that'll even out, because as one pushes, it'll make contact with the other and so on. So you get a good connection all the way along. If you look at one of the back issues of Tips in a Month, you'll see pogo pads covered and various uses for it in there. That's another example of it. And the second reason for doing this in the first place was to show how easy it is to write to a 1602 screen.